Assalamualaikum and good afternoon everyone.
My name is Khairiyah.
My name is Nurul Aliah.
We are from
L1D9,
Mr. Hatta
students.
Okay, today we are going to explain to you about the free body diagram and some forces that acted on the
Certain situation.
defined as a physical quantity that causes an object to move, stop.
And change its direction or change its physical form.
First force that we are going to explain is weight. So, what is weight?
So, weight is force that exerted on a body under gravitational field on or near the surface of the earth. The direction for the weight is always vertically downwards.
Downwards.
It is capital letter W.
To explain is the tension. When a string or rope pulls on an object, it exerts a contact force that we call as the tension force. The origin of this force is not only rope. It could be
String, wire, and
etc. And that the direction of this force is always away from the object. Tension, which means the tension is the same at all points in the rope.
is normal force. Force that is exerted by the surface to an object in contact with the surface. Normal force is always perpendicular to the surface. Is always perpendicular to the surface. For the normal force. Symbol for this force is capital N.
Tension is the force that opposes the relative motion of two surfaces in contact. Is F equals to mu n, which means F is the friction and mu is the coefficient of the friction, n is the normal force. Defined as the force that keeps an object stuck on the surface and prevent its motion. Static friction points in the direction necessary to prevent motion. Kinetic friction appears as an object moves across a surface. Okay. The direction is always opposite the direction of velocity. The symbol of kinetic friction is Fk.
External force, which is a push or pull. The external force is F or Fp. Force is given in the question.
In the types of forces, now we are going to move on to the question that we have prepared for you.
See, there are a lot of questions.
But the question is all about the how to draw the
Free body diagram.
So, question. Aliah, could you read it for us?
Yes, of course. So, the question is, an egg is free falling from a nest in a tree, neglected and resistant. Diagram the forces acting on the egg as it is falling.
It's free fall. So the possible force that acting on this situation is weight force. Why is it so? It is because the egg has mass and due to the gravity, it is pulled downwards. Okay.
In which equation W equals to mg.
Okay. M is the mass, G is the gravity. Okay. So moving on to the free body diagram, it will be like this.
Yes.
Simplest one. The simplest one. Because there is only one force acted on this situation, which is weight force. I'm going to read the question. A gymnast holding onto a bar is suspended motionless in mid-air. The bar is supported by two ropes that attach to the ceiling. So now we have to diagram the forces acting on the combination of the gymnast and the bar. So if we sketch the diagram, it will be like this. And the rectangular shape is representing the gymnast, and two arrows here represent the rope. So we have rope 1 and rope 2.
That is attached to the ceiling.
Yeah, that is attached to the ceiling. Okay, for the free body diagram, we have to draw the axis first. Okay, I'm going to read the question. A gymnast holding onto a bar is suspended motionless in mid-air. The bar is supported by two ropes that attach to the ceiling. So now we have to diagram the forces acting on the combination of the gymnast and the bar. So if we sketch the diagram, it would be like this. And the rectangular shape is representing the gymnast, and two arrows here represent the rope. So we have rope 1 and rope 2.
That is attached to the ceiling.
Yeah, that is attached to the ceiling. Okay, for the free body diagram, we have to draw the axis first. The y-axis and the y-axis and the x-axis. Excuse me, sorry. Okay. So, for this question, we know that we have two ropes. Rope is the agent of tension force. So, we have to draw a straight line like this, upward, and two arrows because there are two ropes that have the same direction, which is, since it attached to the ceiling, so it is upwards. Okay, so the rope is sketched upwards
And
labeled as T1 and
T2.
T2.
Don't forget to label.
Is weight force.
Why weight force?
It is because the gymnast has mass. Mass is related to the equation of W equals to mg. That is why weight force is existed in this situation. Okay.
So, a car is coasting to the right and slowing down. Neck leg air resistance. Diagram the forces acting upon the car.
For the free body diagram, first of all, we have to put a small dot here to represent the object. And then, we redraw the direction of the forces that we have drawn here to here.
This one is kinetic friction, and the downwards is weight, and the upwards is normal force. Prepare for you.
Okay. A box of mass M is pulled along a horizontal surface by a force, horizontal, okay? Fp applied at an angle theta above the horizontal. Assume that the surface is rough. So we assume that this surface is a rough surface. Draw a free body diagram of the box, okay? So, if we sketch the diagram, it would be like this. A rough surface and the box and the
FP force.
FP force.
Which is, this one is external force.
External force. Okay. Now, move on to the free body diagram. First of all, as I mentioned before, we have to draw the y-axis and the x-axis first. Then, we draw a small dots here to present the object, which is the box. We have known that there is an external force applied on this situation, so we just redraw the direction of the external force and then the angle, which is theta, Fp and theta. Okay. Since the box has mass, we could see that there is a weight force acting on it, like this. Always remember that the direction of weight force is always downwards. Always downwards due to gravity. So, we draw an arrow downwards like this. Next is frictional force.
This one is weight, which is the always be the downwards arrow. And then this one is kinetic friction. And this one is normal force, which is always upwards. So,
And the external force.
that's all from us.
We hope that from this video, you could enhance the understanding about forces and the free body diagrams.
So don't forget to like and spread love, kindness, sweetness everywhere.
Thanks for watching.
Bye!